Hi, my name is Jimmy, a former Robot No.1 student, and what you're about to see are 4 World's Tournament Champion robots. This is the Firefighter Robot. It automatically finds a fire and puts the fire out by blowing air. It has 22 individual fire sensors, a fan powered by a motor, a 4-motor drive base, 4 ultrasonic sensors, and a brain that controls the whole robot. The drive base is made of customized Lexan pieces, providing a lot of flexibility while reducing the weight of the robot. The robot is activated by a beeper like this, with a trigger that makes a sound. As soon as one of the 22 sensors detects a fire, the robot will compare between each individual sensor and figure out which one is the closest to the fire. After that, it will automatically run towards the target. Find the candle with ultrasonic sensor, activate the fan, and search for another target after a fire has been put out. And this is what the whole process looks like in real life. This is the recycling robot. It has a gearbox powering the lifting system with 2 electric magnets on it. Looking at the drive base, this robot is using a 2-motor drive with a universal wheel to allow it to move freely even though it's on 2 motors. However, there's a specific rule in the competition saying that the more sensors you use on the robot, the less points you will get. Which is why we decided that we are only using 2 grayscale sensors, which are also called light sensors, on the bottom of her bot to detect lines and perform line tracking. In the game, the robot's mission is to collect the battery and an empty can and put them in 2 separate places. When the robot is running, the electric magnets collect the can and the battery to put them in separate places. Because you get extra points if the can and the battery remain standing in the go zone, we added these 2 axles on the 2 sides of the electric magnets to keep them in their position. And that was basically the whole run of the recycling robot. Moving on to the Alpine Bar. The task of the Alpine Bar is to climb up a very steep inclined plane, and at the end of the inclined plane there is a platform for a robot to do missions and challenges on. But climbing the inclined plane itself is very challenging, especially when the inclined plane is about 80 to 90 degrees. Which is why we have a huge fan in the middle of a robot that has so much suction to the floor that the robot can even just climb up a wall, like Tom Cruise climbing up a building with sticky gloves. As in the video, you can see that the fan is so strong that it's blowing the ball so high up. The battery on the robot also has to be very powerful to provide energy for a fan that can literally send the robot flying. In order to make the robot to climb up the inclined plane, we definitely need a lot of friction between the robot and the floor, which is why we chose to use caterpillar tracks to provide as much friction as possible. The robot have 2 motors powering 2 caterpillar tracks and 6 wheels in total. Most of the parts on this robot are 3D printed, like the fan tunnel and the base, because 3D printing materials are light and stable. Last but not least, there's a claw built on the front of the robot to complete tasks on the platform, with ultrasonic and grayscale sensors to detect if the robot is at the edge of the inclined plane or not. And if it is, it can easily reposition itself. Moving on to the Maze Runner, this robot is very special because it's very lightweight and it's very small. The Lexan pieces on the bottom are all customized. The 4 wheels are connected by 2 gearboxes and 2 motors, with special encoders inside them to keep the robot balanced. And the builder have to make very careful choices about what to build and where they put it. For instance, all the motors are built on the outside of the robot because all the wheels had to be touching the ground. The task for the Maze Runner is basically running on a wooden road without falling off the edges all the way till the end. Sounds pretty easy, right? But the thing is, you cannot use any sensors at all, but only using the internal encoders inside the motors to track its position, which requires a lot of testings and patience. And that was it for the short introduction. Thanks for watching.